going to try to show you what I did with DynamoDB and Spring in a project I worked at the Cloudsoft. So for those that do not know me, which probably it's most of you, except the guys I had a pint with like a few nights ago, my name is Iuliana Cosmina. I am a full-stack developer at Cloudsoft Edinburgh. I am a Romanian living in Scotland, and I got totally used to being out and about without getting burned, and Barcelona is killing me right now. I am also a technical author for Apress, and because one of the most important projects Cloudsoft has was donated to the Apache Foundation a few years ago, I'm also an Apache committer. It's an orchestration software for various cloud providers. You can find me on Twitter, or you can Google me, and from there, I'm pretty sure you'll find me, because I've been producing content, either technical or, I don't know, you could call it literature. I have a personal blog. So Google knows who I am since 2006. So I'm very, very easy to find. I have about 16 years of experience in working with Java, a little bit less with Spring because I only got certified in 2012. Yeah, and the way I number my years of experience is since the moment I actually started paying my rent from the salary I got for doing software. So yeah, that's pretty much it. I don't know what else to tell you. Just, yeah, if you want to know anything else, we can figure this out later. So let's get this done. So disclaimer. Actually, this talk was actually refused initially for Spring.io because it was very difficult to talk about something without telling you a lot about the context in which this bit was used. So the project that I extracted all this information from is currently in alpha status. Our clients are evaluating it, and we're trying to get it to a very good production status that we can maintain without hating ourselves. So I can't tell you a lot about the context, but I tried to show you a little bit the architecture, the tech stack, and the main focus is the DynamoDB bit, which honestly, even with a little bit of obfuscated code, it should be quite obvious what we're trying to achieve there. So yeah, that's the situation. And you can ask me questions about it, and maybe I will tell you, but I'm not going to divulge more than I should. So this is my plan. I'm not sure how the execution will go, but yeah, I will show you the architecture, give you some details about the initial tech stack and what we've evolved into, and then focus on the challenges of working with DynamoDB. And at the end, if I manage to finish in about 30 minutes, because that's my plan, we're going to have like 20 minutes of questions and more like a technical discussion about what you've seen and about how you would have done it if you want, and so on. So let's see. This is the architecture. It's very simple. It doesn't have that many moving parts. We have a static front end built with TypeScript and React, which is stored in an S3 bucket. And we put CloudFront in front of it in order to cache our resources. Our backend, it's a Spring Boot REST application that we get authenticated to using Amazon Cognito, and it's being deployed on one or more EC2 instances. It really depends on how many people are using it, and that's why we have an auto-scaling group, which will create as many of those instances required. And in order to make sure that each client will get like a professional experience and everything will be responsive, we also have a load balancer which will distribute those requests evenly. So I'm not sure how much you worked with Amazon, but by now I think I covered the core components that you will find in mostly everything that is built with Amazon. And our data is stored in a DynamoDB table, which is being populated and sometimes processed and so on by a suite of AWS step functions. As for the developer tools, we've used Terraform to deploy our infrastructure. We use Circle CI for continuous integration and for running tests. We use Git for versioning, and for testing it or running certain things locally, we use test containers. that's pretty much it. I don't know if there's anything else. It's simple, right? I mean, it's not complicated, and what it does is quite nice. It improves certain aspects of our client's experience with AWS services, especially when you use a lot of them, which is quite paradoxical because we use a small number of Amazon services to help you manage a shitload of them. Anyway, let's continue. So, migration. When we started developing this in 2020, we went with a familiar tech stack. Cloudsoft already had experience with using OSGI and Karaf. If you're familiar with OSGI, it's the initial modularization thing for Java that was supposed to become the Java modules, but that didn't happen. So that means your application was basically a bunch of jars called bundles, and they needed to be managed by a container, and that was Apache Karaf. So we had this set up on that Apache Brooklyn, the orchestration software that is open source that I told you about. We have that in the enterprise version of it. And upgrading libraries, it's a pain because all these clashes, they just propagate everywhere, and there's these huge stack traces. And we realized that it's a problem for such a small project to have so many tricky moving parts that if one broke, everything everything would shut down. Well, shut down, not be useful anymore. And this became especially obvious when the on the log4j problem happened, the vulnerability in December, because we had all our OSGI projects. We started upgrading them in order to remove the version that was problematic, and then the stack traces and the problem started like on all of them. So it's like, okay, what we do, Apache, we have to fix Apache because it's public, people are using it, it's open source, let's do this. Plus, we can't fix our enterprise project built on top of it unless we fix Apache Brooklyn and so on. So at the time, it was like, you know what? We have a Spring expert in-house. Let's just ditch OSGI. And this is what we did. And since you ditch OSGI, you ditch bundles, you don't need the bundle container, right? And then, since you're not stuck on Java 8 because of the specific container manager, bundle manager, you're not stuck on Java 8 anymore. And since you also have a Java expert in-house working with the most recent versions, we jumped directly to Java 17. And I wanted to use a lot of records and seal classes and all the goodies that come with Java 17. But then we realized, actually, we need to use some bits of this code in our AWS Lambda functions, and AWS didn't offer a runtime for Java 17. It only offered for Java 11. So we stuck to 11. So it's fine. It's better than nothing, right? It's not 8 anymore. So we also had an in-house security module built that was it has code everywhere where a request was being made in order to make sure the actual person that was doing it was allowed to do it. So I stripped that up and put Spring Security, or at least that was the plan, and then Spring Boot and everything else connected to that. So that's when things started to go weird. So all these 5 things here, like removing Apache Karaf, upgrading Java, restructure the modules, because we had all the code base in one project, and now when we had a better design for it, we had to strip it and organize it more nicely, right? Introduce Spring Boot and set up Spring Security. Obviously, only me, I could do this too. And then, in order to introduce two, I had to do this. And of course, Java is not a big thing, but then again, you just change the version number in a poem, so what's the point of separating it from the rest of the tree? And when you remove Apache Karaf, you actually get to the restructure of the module, so you couldn't split it. So I had to do all this, while my colleagues used the old version to develop features that our marketing team was actually looking at in order to create demos and things to woo our potential clients with. So yeah, after doing all this, I also had to make sure that I include their features, and it was fun. It was really, really fun. And this is what I heard for 2 months while I was struggling with this, trying to make the decisions and then going back and forth with some colleagues, because even if they didn't like Spring because of the overhead and extra dependencies and stuff, they were still like, are we there yet? Can we use it already? I'm like, oh my God, it will happen. Just give me a break here. And haven't done Spring in production since 2012. Yeah, that was also the case. So yeah, different versions of that. Is it ready, Iuliana? When it will be ready, Iuliana? Can I use it? Can I test it? Can I? Yeah. Okay, fine. So that was those were the moderate challenges, because the biggest challenges was to design the DynamoDB table. And oh my God, when you have like 5 developers, it's difficult. And imagine if you had more than that. We were 5. Design the DynamoDB table. We wanted to go for a single table design because this is how DynamoDB is supposed to be used. And we had to define the permission model. And we did that twice. I think we designed it once, we were all happy with it, and then some senior guy from our company came and like, no, I don't like that, we need to do this and this. Okay, fine. And then we have to implement the Spring part of it that would communicate with data, and we had to create the data classes, that model, the model classes, and so on. So if you're not familiar with DynamoDB, this is the point where I should introduce a little bit why we wanted DynamoDB. So DynamoDB is one of the most scalable, reliable, and fastest databases, NoSQL databases currently on the market, available as a service from Amazon. They created this especially so it could satisfy the needs of a shopping site such the Amazon, right? So if you ever go and search for an item and you are like, wow, how does this comes back to me so fast? That's because that's a DynamoDB configured to a professional level by people that designed it, and they know exactly where to tackle it to make it work best. So what's the catch, and how can it be described? If you studied in university, I think you remember, if you studied computer engineering or computer science, I think you remember the 5 stages of normalization of data, right? Well, you start with a big table, with data duplication, and then you remove that duplication in order to create smaller tables, avoid data duplication, create relationships between tables, and then when you need to extract data, you basically navigate those relationships via joins or views and so on. Amazon threw all that out the window, and they kept the big table. They said, okay, storage doesn't cost us that much. We rather had a little bit of duplication in the name of performance. We want data fast. We don't care if it comes from this line or that line or that line. It's simple, right? I mean, you don't care where it comes from, as long as it does, eventually. Because that's the thing here. It's the data will come to you eventually. Anyway, so this is how, in part, it's a little bit obfuscated. Like I said, it's not always the same, but we do have organizations. So this you can believe me, we do have organizations, we do have users, we do have team. Tasks, and resources. Those also we have them because they map to Amazon services. So in order to identify the data you need in your DynamoDB table, you need the partition key. This is actually the most important part of this table, and that's actually, I think, the only mandatory requirement when you design your table, because this partition key, in our case, our organization, groups your data in partitions. So when you need to extract something, this is where you start. You're telling it, this is the only part of the table that I want you to search for my data, which is good. I mean, imagine that for Amazon, you have, these partitions are like 10 gigabytes or something like that. They're huge. They are huge. And then once you have your little table determined by your partition, you know that search is usually more efficient in a collection that is sorted, right? Well, although not mandatory, it is recommended to have a sort key. So that's the sort key. And as the name says, its purpose is, when you introduce data, is to put related data to each other so that when you search for it, it will be returned to you in continuous chunks. So that means you have some restrictions on what you can do with this sort key, because you can't have a filtering that will return pieces from here and from here and from here unrelated. It has to, the filtering condition that you are allowed to use has to ensure that you get a continuous chunk. Otherwise, it won't work. And you'll see that in case you need something like that, it gets really complicated. So that's our table. The permission model that I told you were redesigned twice and that I think is causing a lot of problems and I think it will suffer redesign is actually this bit here. Because tasks can be assigned either to a user or a team. And there are certain things this entity can do with the task based on the role. So my permission model is represented by this map here in this attribute. So yeah, imagine if filtering on string is fine, on numbers, filtering on maps, not so much. Anyway, so that's pretty much it. And the partition key, together with the sort key, they combine into a primary key, which uniquely identifies a row in your table. OK, another thing that I have to mention before I jump into code, because I think that's what you're all waiting for. In case you have a different way of identifying your entries, you can also declare global secondary indices. I think you can, by default, you can use 2 of them. So you can use like a secondary partition key. So you're partitioning your data based on a different attribute. And you have a secondary key, which the same. They have the same purpose as you've seen in a table, only in this index. And we decided that, OK, some of our entries, we are interested to have them in this index. Not all of them, but some of them we want to be able to access fast and get the chunk of a bunch of resources of the same type. So the primary key in this index is basically this attribute here. And I know the name is not really inspired, and surprisingly, that one is not obfuscated. That's exactly how I named it to make sure I know what that is, and everybody else does in the company as well. The GSI1. Like, okay, very, very creative, I know. Anyway, so using these two, you basically get a secondary primary key for your table. So that's it. That's all. I'm not a DynamoDB expert. I just learned enough for it to do my job in Spring. So most of the design was like a team effort. So let's see. So how do you work with Spring from this? Well, you need to connect to the table. Well, you need to tell Amazon, hey, give me the data from there. And this you can do by using their AWS SDK for Java. And you get a DynamoDB client from that SDK. And in version 2, this DynamoDB enhanced client was introduced. And as the name says, it should offer more practical ways to query your data, to construct queries in order to get your data. So yeah, so the Dynamo enhanced client, it comes from AWS SDK 2. And it has been released. It's stable, so I want to use it. Yeah, that's what I do. If it's official, if it's accepted, it's an official version, a final version, I will use it, sort of final. So that was the configuration class. So a repository. When I initially started working on this, I got scared. I was like, what the hell do I have to, if there's no Spring data for DynamoDB? Well, there is, but it's not production ready. What do I have to do? Do I have to create a Hibernate for DynamoDB? What the hell am I even doing? Do any transactions? How will this go? I had a little bit of a panic moment there and a few nights with lack of sleep, realizing in the end that it's easier than I thought. So in order to get your data, you can either get it from the main table or you can get it from the index. And for that, you have 2 types of objects. You have the DynamoDB table and that DynamoDB index. And when you create your repository for a certain type of entry, what you do is use your Dynamo enhanced client and just create those 2 instances based on it. Ah, shit. I moved too fast. You create your resource table and your resource index based on that client and the table schema. So here's the thing. In order to map your data to some Java classes, you need one of these table schema, bean classes. They have special AWS annotations, and Yeah, I don't have time to go over that as well. Just believe me, they're quite similar. That if you want something that, if you want to associate it to something that you already know, you know the entity classes for JPA? That's kind of like it, only you have like AWS SDK annotations on them, telling you which is your partition key, sort key, and other things. So one thing you have to notice here, that obviously when you create this repository or you create one of those DynamoDB table in index, you are stuck to a certain resource type. So if I would need to get a user with all his tasks, with all its resources, I can't do that with this. With this, I can only extract resources. And it's called resource-db my type because we actually have a service type that wraps around it and does some cool things with the data from the table. And this is how the easiest and the scenario that you want most in your application you want with DynamoDB. Here's the thing, if you design your table well, and if your data is structured well enough that you only need the partition key and the sort key, you're in luck, because this is just one request, and you can extract your data doing one request just based on your partition value and your sort key. And it's fast, and it's easy to write, and it works. So for simple scenario, this is very, very easy and practical. And all these classes that you see here come from the AWS SDK, and they work as intended. When you want to do something more complicated, like you want to extract multiple layers of your entries. So for example, if I want to extract all the tasks all the tasks that the user has access to, which in this case means tasks assigned to the user or tasks assigned to the teams the user is part of. This is where we have to do that filtering based on the permission model, the map that I showed you and I pointed your attention to. So how do you do that? Because you obviously you can't use one of those repositories or one of those DynamoDB table, right? So there's before getting to the Java part, let's see like the DynamoDB part. So there's an operation called scan that does exactly what the name says. Scans the table, and with the filter expression you can get your data. Problem is, scan is highly inefficient on huge tables. And we think big, very big. So we avoid scanning like the plague. So that means the second thing, what should we do? Should we should we query with a partition key and a filter expression for some of our attributes? Yeah, that is good as well. Problem is, that sort key, it's not really flexible when it comes to what the conditions that you can put on it, because you need to get that contiguous chunk of data. So query on a secondary index, well, if we would have designed it better at the time, maybe it would have been possible, but So what I did is a combination of the two. So this is what you expect when you try to retrieve the tasks that the user has access to. Tasks and resources, so tasks that the user is directly assigned via that map, or teams it is part of, and resources for that. And the sort key, probably I should have explained a little bit the key structure that is also flexible. You can define it any way you want it. Just as long as you have a primary a partition key and a sort key, all is fine. We define our sort key to start with like the parent of the entry. So if you have multiple resources that are linked to a certain task, their sort key will start with the task ID, and this means they will also be in your table. They will be found all together in a continuous chunk, right? So in your table, when you search for them, you'll always have them in a row, one after the other. Okay, so how do you do this? Well, the service method per se looks like this. And it's about 3 requests, because I need to extract the teams first. And then when I load the resources, I need to extract the tasks first. So in the code that I will show you, I'm going to jump over the teams part because it's not really that interesting. I'm going to jump over the task part because that's easy as well, because I know the task ID and I know the sort key ID and I know the partition key value. I'm going to jump directly to resources, where I have something like this. So I only have the partition key, which is still good because it allows me to do querying. But this code that you see here is just creating the expressions that the sort key needs to abide by. So or I'm using to filter those. So I need all resources where their ID starts with the task ID A or task ID B or task ID C. So you can imagine the way my condition looks like. I'm going to get different chunks that are not together in one. So I need to do this crazy thing here. And the annoying part is, you can see those are strings. Well, it begins with, it's a function, but actually the way I write it in Java, it's a string. So if I mess up one character, I won't know until I actually run it. So yeah, it was a little bit of pain to figure out what I have to do, but I did it. And as you can see, I used the attribute that I designed for my global index, global secondary index, as an attribute in order to do the selection on the table, because I needed it. That's how we designed it, and that's what I could do with that data. And yeah, so this is, once you have those expressions, this is what you do. You put them into a query request, and that query request, you pass it over to the basic DynamoDB client, and then you get your results as a list of maps, which then you have to convert into resources and assign to the tasks. It's simple, right? But once you do it, it seems logical, but no. Anyway, so what I have to tell you here is that basic DynamoDB client, it's not the enhanced client, because the enhanced client doesn't know how to do this, the query request. So yeah, that was my surprise as well when my colleague that has a little bit more experience with DynamoDB with me was like, Iuliana, you can do it. It's possible. How? I was scanning through the Java API, and where is it? What should I use from here? And in the end, yeah, okay, just give up the enhanced client, just use the basic one, because that's the only one that can do it. Okay. And bonus, I told you that a bit of our code had to be used in an AWS Lambda function. And from a developer's point of view, what is a Lambda function? It's a jar that you give it to Amazon to run on their AWS Lambda computing thing. So that means your jar has to be executable, but not in the way you're used to with Spring Boot. You don't have a main method as your entry point. Your main method is actually a handle request. So you have to use the AWS SDK and implement that request handler interface and make sure all your code is in here. So that means when Amazon calls this, when AWS Lambda calls this method, everything that you might need for your application has to be initialized and usable. So that means, yeah, sure, let's do a Spring Boot application. Let's see how that works. Well, that doesn't work, because a Spring Boot application wants the main method as an entry point. So even if you would do it, yep. Okay, even if you would do it, you would have a lot of Spring dependencies that maybe you don't need, because your jar has to be small, has to be compact, has to be one thing, has to handle one request. Why would you have all those dependencies in? It makes no sense to have a Spring Boot application. So this, as you can see, the name of my colleague there, it's Duncan Grant. He started this and initially was trying desperately to put Spring Boot in there, to just shove it into AWS Lambda. And Amazon was totally opposed to this. And he was like, yeah, no, this is not working. And okay, why do you need Spring Boot? Like, but how do I do it without Spring Boot? And that's one of the tricks. When you start using Spring Boot, you start missing the fact that you can create your configuration from scratch. You can create your application context empty and only inject the beans you need. Also, here I think we have a little bit too many, but still. Anyway, so that's what I did. I added this static block. I created an empty configuration. I put exactly the configuration classes that I need, refreshed, got my repository that then is being used here, and it's performed the request that I need. You don't need Spring Boot, and you shouldn't try to do it in AWS Lambda. Yeah, so this is all you need. Just build your minimal application context, and you should be fine. You can do it, and it will work. Okay, so I think I'm done. I'm not sure how much I went over the half an hour that, oh, I didn't, yes! Okay, cool. So what I liked about this experience, I haven't used Spring in production since 2012. That was a long time ago. I only wrote books about it. And I liked writing books about it, but I wanted to solve real problems. My colleagues always say that, a few of them, not all of them, say that Spring, it's heavy, that it brings a lot of unnecessary things. But when you work with Spring, you can strip out things that you don't need in your application. You don't need to keep everything. I mean, of course, default, in order to have something running fast, it works, but you can strip it and only keep what you need. And I'm an old school developer, and I do like to keep things small and compact and not pay any cloud provider more than I have to. so small, efficient, consume the less memory possible, take the small amount of space, and so on. So there are no transactions to deal with, well, unless you want to do like batch writing and stuff like that, but otherwise, DynamoDB deals with requests that you don't have to manage or synchronize because they are just resolved in the way they are received. So it makes things simple because, yeah, there is a lot of code that you don't have to write and a lot of problems you don't have to solve. There is a Spring Data DynamoDB, but it's not production ready. I think the examples I've seen it used with, it's actually using multiple DynamoDB tables. It's almost relational, and it's no SQL. What are you doing there with it? But what it could do for me, the version that I would like to see, it's one that would help me write those queries, those filtering expressions in a more reliable way, so I don't have to figure out, oh, did I wrote a small letter here or a bigger one, and I'm tired and I can see, why is this not working? And so on. So that is what it could do for me. And I imagine now, since DynamoDB is so flexible, because you can design that table any way you want to. So each developer will have a different idea on how that table should look like. And it's the same for keys. You can decide how your partition key looks like, how your sort key. I imagine you could standardize it and provide it just some functions that will create the function, create the key for you to get a little bit of a standard in there. Spring cannot help too much in harnessing DynamoDB. It's your talent in querying and your talent in designing your table that saves you. And the difficulty of working with DynamoDB with Spring, it doesn't come from Spring per se. Spring is great. It comes from the fact that from my experience with DynamoDB, and not only that, Java is not really a first-class citizen in the Amazon ecosystem. I've seen examples working with Python or written with JavaScript, and the fact that you don't have a static type helps a lot, because indeed you can design one of those very complex filters that does one request and extracts everything you need. But if the SDK limits your querying to that table, DynamoDB table instance, which takes a generic type and limits it to a certain type of entry, it doesn't work. So yeah, I think Python and JavaScript is the way to go. Yeah, I think it will be better, and we're actually considering for the next version. Also, Spring Boot is not a good fit for Lambda functions. Stop trying to do that. So I did this presentation 2 times with my colleagues at Cloudsoft, and one of them said that, how could I explain to people better why you shouldn't use it? Well, and I thought about this analogy, and it's going to be, I hope it works for you as it works for me. Imagine that Amazon is a gym. What would be the point for you to take your stationary gym from home to Amazon? There are already stationary bikes there that you can use, right? And after I did the first presentation and I mentioned this allegory, one of the colleagues said, well, you should make it obvious why it's hard. So yeah, that is me lifting one of the stationary bikes at my gym. So yeah, you don't want to do that. You don't want to just walk with that around, and it's not going to fit the door. And Amazon is a business, and they sell you their own things. You don't have to bring your own things in. Just use what they give you. That's the best thing. So yeah. That's all, folks. I tried my best to entertain. I hope I didn't put you back to sleep. Thanks very much for having me. Yep, that's it. Cool. So I'm gonna switch from this to this because, yeah. If you have questions, I will try my best to answer. If not, let's do this. Hey, of course, you, obviously.
Thank you. Can you hear me? Yes.
Yes.
What was the reason to not choose a relational database?
Like I said, we dream big. If you ask me, I told them that to me, the data that we're handling seems quite well structured. Why aren't we doing? I think what the consensus of this was that, oh, but we want it to be fast. Okay, it's a team. I don't have to agree with everything my colleagues say, with everything my colleagues decide, and if we vote and they said DynamoDB, I said, okay, fine. I mean, I'm okay with learning something new, and we'll see. I mean, this was a prototype at the time. So at Cloudsoft, we have a lot of customers, we switch from project to project, but sometimes we do have more relaxed periods. And those relaxed periods, we maintain Apache Brooklyn, and we start creating toys like this. So sometimes they actually end up making us money. Sometimes they don't. We just learn about what not to do in the future. So yeah, that's the answer. If you ask me, I'm on the same opinion. I think the data could have been structured and we could have used something relational.
Thank you.
Pleasure. No.
So you mentioned that Spring Boot is not a good fit for Lambda.
Yes.
What about Spring Native and Spring
Oh,
Cloud
I was
Function?
pretty sure you're going to ask that. So I'm not sure when Amazon is going to decide to jump on that bandwagon, because I'm not sure in the status. The last time I looked at it, it was like a few months ago. I think they were still experimental, right? Yeah. So Amazon, sometimes it decides to stay a little bit behind the trends in order to keep things stable and secure, because anything that goes into production must be audited, must be have the little vulnerabilities possible and so on. So I imagine until it gets to a status where it's really stable and it's going to be like have the trust, or that it will pass the test of being used a few years, now, well, not years, because now we're moving fast, a few months. I don't think they're going to do it. They're not. I mean, we were stuck on Java 8.11, yeah, and 17 was already there, and everybody was saying that it's great, and I'm saying that it's great, and I want to use it, and I can't. So you go to a restaurant, you can bring your own food, man. Yes. Can't have your cake and eat it too. I think this is why I like writing books, because I can use the most recent libraries and technologies, and I can try to do whatever I want with them in ways that I'm not allowed to do in production. So yeah, that's it. Are we done? I'm going to have a coffee. Yay! Thank you.